Hello, Math 2 students. I hope you're ready to learn about special right triangles. Triangles that are half of an equilateral triangle, or in other words, a 30, 60, 90 right triangle, or triangles that are half of a square, or in other words, a 45, 45, 90 right triangle. We'll learn how to find the missing sides of these triangles without even using the Pythagorean theorem. Make sure you have your notes out and do these 5 examples along with me. Example 1, find the missing side of the triangle. The first step in this problem is to make a decision about what kind of related shape this triangle has. Is it related to a square or related to an equilateral triangle? Well, my first clue is that these two sides of my triangle are congruent, which means these two angles must have the same measure. So my triangle is a 45, 45, 90 right triangle, and that is half of a square. So my related shape is a square. So now I'm going to draw that related shape, and I'm going to label it the same way my problem is labeled. So I have one side of my square that's 14. I have one side of my square that's A, and the diagonal of my square is B. Now, since I know that this is a square, I know that every side is the same. So this side will be 14, this side will be 14, and A, the first answer that we're looking for, will be 14. Now, I also know that the diagonal of the square is the same thing as the hypotenuse of the 45, 45, 90 right triangle. And I know that the diagonal of the square, the pattern is that it's always the leg multiplied by root 2, or the side of the square multiplied by root 2. So the value of B in this problem, or the length of line segment B, is 14 root 2. Example 2, find the missing side of the triangle. Again, we can see that this is a 45, 45, 90 right triangle because there are two congruent legs. It is isosceles. So there's going to be two congruent angles. So this is related to a square. So now we'll draw the related square and label it the same way that the 45, 45, 90 triangle is labeled. Well, the side across from the 90-degree angle is 11 in my original picture. So that's the diagonal of the square, which is 11 in this picture. And then C and D are two of the sides of my square. And I know that those are going to be the same because a square has 4 equal sides. So if I can find one of those sides, I will be able to find both of them. But this is one of those things where when you're looking for the side of the triangle or the diagonal of the square that's related to the square root, it can become confusing. So here's how I can write an equation. Normally, I know that if I take side D times square root of 2, it will give me the diagonal, or side D times square root of 2 will give me the hypotenuse of my 45, 45, 90 right triangle. So on this problem, it is 11. So now I have to solve this equation for D. So I divide both sides by root 2, and I find out that D equals 11 over root 2. That's a fine answer, except we're not allowed to have square roots in the denominator of our fractions. So I'm going to rationalize by multiplying the top and bottom by root 2, and that will give me 11 root 2 over root 4, and 4 is a perfect square, so my final answer for D will be 11 root 2 over 2. And if that's the length of side D, then that will also be the length of side C. Example 3, find the missing sides of the triangle. In this problem, I have a 30-degree angle and a 90-degree angle. So I know that this angle right here must be 60 degrees. This is not half of a square. This is half of an equilateral triangle. So now I'll draw the related shape, and I'm going to label the shape exactly the way it's labeled in my problem. So I know that this is 10, this is E and this segment is F. So I need to use what I know about equilateral triangles and the patterns in equilateral triangles to help me find side E and F in this 30, 60, 90 right triangle. Well, I know that every side of this equilateral triangle is going to be 20. So I've solved for side E already. I know that this is an equilateral triangle, and if that half side is 10, then all of the whole sides are going to be 20. I also know that the height of this equilateral triangle, or the longest leg of my 30, 60, 90 triangle, is the part of the triangle that involves the square root. And the pattern is that if I take the shorter leg times root 3, it will tell me the longer leg. Or in my equilateral triangle, the height of the equilateral triangle will always be the half side times root 3. So the value for the length of side F is going to be 10 root 3. Example 4, find the missing sides of the triangle. Again, there's a 60-degree angle and a 90-degree angle, so this needs to be a 30-degree angle. So I know that this is not half of a square, this is half of an equilateral triangle. So I'm going to draw that related equilateral triangle. And now I'll label it exactly the way it's labeled in the picture. Opposite the 60-degree angle is a 12. So the height is going to be 12. Opposite the 90-degree angle is side J. So opposite the 90-degree angle is side J, and opposite the 30-degree angle is side K. So this is a more difficult problem because the segment that's related to the square root is the segment that I know. So in the equilateral triangle, that is the height. In the 30, 60, 90 right triangle, that's the side, the longer leg that's across from the 60. So I'm going to have to write an equation. And here's how my equation is going to go. Normally, I take side K times root 3, and that will give me the height, which is 12. Now, when I solve this equation, I will know the length of side K. So I need to divide both sides by root 3, and I get K equals 12 over root 3, which is a fine answer, but again, we can't have a square root in our denominator. So I rationalize by multiplying by root 3, and I get 12 root 3 over root 9. And I continue to simplify, and that will be 12 root 3 over 9 is a perfect square, so the square root of 9 is 3. Then I need to reduce, 3 goes into itself once, and 3 goes into 12 4 times, and I find out that the value of K, or the length of that side of the triangle, is 4 root 3. So on my picture, K is 4 root 3, and I know right away that this entire side is 8 root 3, which means that side J is 8 root 3. Example 5, find the missing sides of the triangle. Again, this is a 30, 60, 90 right triangle. So I know this is related to an equilateral triangle. And I need to label it the same way that it is in my picture. So opposite the 90-degree angle is where I find 8 root 6. So I label 8 root 6 here. Opposite the 60-degree angle is where I have the variable h. And opposite the 30-degree angle is where I have the variable I. So in this problem, I know that one side of my equilateral triangle is 8 root 6, which means that every side of my equilateral triangle needs to be 8 root 6. And my half side is 4 root 6, which means that letter I is 4 root 6. Now I know that if I take my half side, my 4 root 6, the shorter leg of the 30, 60, 90 right triangle, and I multiply it by root 3, that will tell me the height of the equilateral triangle, which is the same thing as the longer leg of the 30, 60, 90 right triangle. So to find h, I'm going to need to go 4 root 6 times root 2. And so that's going to give me 4 root 12. And we can't leave that answer the way it is because 12 can be divided by a perfect square, 4. So h equals 4 times root 4 times root 3. So h is 4 times 2 times root 3. So h is 8 root 3. All right, after watching this video, you should be able to find the hypotenuse of a 45, 45, 90 right triangle when you know one of the legs. You should also be able to find a leg when you know the hypotenuse. In a 30, 60, 90 right triangle, if you know the shorter leg, you should be able to find the longer leg and the hypotenuse. If you know the longer leg, you should be able to find the shorter leg and the hypotenuse. And if you know the hypotenuse, you should be able to find the longer leg and the shorter leg. Thanks for watching.